Algebra 2 Polynomial Functions. Factoring polynomial functions. In the previous video, we went through the polynomial functions basics characteristic that include the roots and minimax and the direction of the curve going either up or down. So we look at the polynomial equation. You can tell how the graph on the xy coordinate looks like. In that characteristic, the one of most important characteristic is the roots. Let's see, we have a two quadratic equation. Okay, there are two roots. Number of roots is dictated by this x to the square. So x square generate two roots, and the way we calculate the roots is there are two ways. One is factor it. Second way is use quadratic equation, and these are the one these two methods we learn in Algebra 1, I hope. Factoring is we make a function r1 r2 this way equals 0. So y equals 0. So we know intercept on the x coordinate is r1 and r2. So r1 r2, it's going to be either this way or either this way, right? Depend on the sign of the coefficient on this most significant term. The polynomial, this is least significant, this is most significant. The number on the right shoulder of the x, this determines which one is most significant and the least significant, right? So depend on the coefficient for most significant term, the which way it's look up or look down, it's decide. Quadratic equation is determine the min or max point, and from here you have a distance, you add or subtract to determine this. Okay, so since it's a quadratic equation, is always symmetric, the distance on the right and left side are same. Now polynomial, you may have the third degree, which is x to the 3, and it's become a little bit more complicated because there's no equation to solve the root directly. Okay, well, there is for finding roots for third degree x to the third. It's pretty complicated, and it's not generally used. And what you can do is only factoring. You just hope you can factor it. Okay, when I say you hope, means most of the math exercise question is made so that you can find the way to factor it. So you can find out, in this case, root is 1, -1, -3. Okay, so this is the only method you can do, and something equivalent to quadratic equation for third degree exists, but it's quite complicated and it's not used commonly. Okay, Can you do this formula? How about this? Well, actually, this gets very complicated. The certain point when you increase the degree, you cannot solve. It's not guaranteed to solve. What do you mean you cannot solve? Well, you can always get the roots number by the method we talk about later, but there's no formula provided, because the formula can use only add, subtract, multiply, and divide, and square root or square third or whatever. And this math operation is not enough to obtain, for example, x to the fifth root. You need something else. And so we define this as not solvable. Okay? The polynomial, when the number of degree increase, then it's become not solvable. Well, of course it's solvable as long as you can do factoring. Even equation has 6, so if you can factor, you can solve it. But general solution, the formula cannot be created using only those math operations we are aware of. This has become a little bit more absolute math area, so we don't get into too much. But if you can factor it, you can find the roots of polynomial. So since we learn quadratic, how to factor the quadratic equation, now here's the x to the third plus a to the third. So this is negative. In this equation, you can get factoring on one side. This one cannot be factored completely. So what's happened is, this is the quadratic equation. Use quadratic equation formula and obtain the roots, and this is guaranteed to be a complex number root. And this case also same. You can factor the first term. Second term, you cannot factor it because the root will be complex number. Now, triple roots. These are the lucky case. Coefficient 3, 3, and that can be factored into this triple roots case. And in this case, the root is negative a. This case, pay attention to the sign, okay? Then we can factor it into triple root, and in this case root is a. Okay, so example is this one, negative 6, negative 8, and 12 here. Okay, so what is the value here? A is 2, right? Negative 2? Nope, if you write this, it's 2. So root is 2 in this case. Is that right? 2 times 2 times 2 is 8. And 3 times 2 is 6. So that's the way you do it. And when you have a higher order term, what you do is try to factor out whatever you can factor out and leave the remaining. Okay, and try to factor out something else. So one by one, if you're lucky, there's no guarantee, you can reduce higher orders polynomial into, you can reduce the higher order polynomial to lower ordered polynomial by factor out some terms. Okay, so that's the strategy to use. It's not perfect as a math, but you know, it's important to know the limitation of the math solution here. Problem get complicated when it's become polynomial. Okay, so for example here, if you do this, what is ABC? What you do is try out some simple number like a 1. So it's a 1 plus this x squared, and third 3 minus 1 minus 3. So 1 works. So a can be 1. So if you reduce the a, what you do is you can divide x2 minus x minus 3 and x minus 1. X squared, so x third minus x squared. So 4x squared minus x, right? So next one is going to be 4. So 4x squared minus 4, 3 minus 3x minus 3. So plus 3. So the remaining is going to be x squared plus 4x plus 3. Right? So the remaining, we have to factor this one. How do you factor it? 3 and 1, x plus 3, x plus 1, right? 3 to 1 is 3, 1 to 1 plus 3 is 4, right? So remaining is going to be negative 3, or here the b is 3 and c is 1. Okay, so you can factor into this. Let's try next example so you know what I mean. This is the fourth order. So the hint is you can factor into, this is the double roots a, b, c. Okay, so as usual, try the simple one. Say x is 1, 1 minus 3 minus 3 plus 11 minus 6. Does it work? Yeah. So x is 1, right? So what you do is x4 minus 3x minus 3x squared plus 11x plus 6. And a is 1, so x minus 1, x3, x4 minus x3. So that's gonna be minus 2x squared, third minus x squared. So minus 2x squared minus 2x third plus 2x squared. So minus 5x squared plus 11x and minus 5x. So minus 5x squared plus 5x. So it's going to be 6x plus 6. So it's going to be plus 6. This 6 is negative here. So it's negative. So after we determine a is 1, remaining is going to be remaining term is going to be 2x squared minus 5x plus 6, right? Now we know there are double roots in here and another root, and let's try 1 again. So it's going to be 1 minus 2 minus 5 plus 6. It works. So 1 is another root. That means a is not 1, b is 1, because b is double roots, right? X minus a, x minus b square, x minus c. So b equals 1. So we have to divide this by x minus 1 again. So x square, so minus x square, it's going to be let's see here, x to the third minus x square, so minus x square minus 5x, x minus x, so x square plus x, so minus 6x plus 6, so minus 6. Okay, so remaining term for this question is going to be x squared minus x minus 6, right? So this is going to be x minus 3 and x plus 2. Is that right? 2, 3, 6 and negative 1. Okay, so we got it. Another one is 3, another one is minus 2. So this question, a is 3, b is 1, it's a double root, and c is negative 2. Okay, we solved it. Okay, so next one is roots and minimax. So what we need to know is we can tell at least there is a local max, local min, and root, and the root can be like this. Okay, we kind of know how the function shape is. Then we can use computer to calculate the exact root. As I said, the polynomial, generally speaking, you don't have a general solution. You cannot solve all the time. Only when you're lucky, you factor it. You could factor it, you can solve it. If you cannot solve it, what do? You kind of figure out the shape of the waveform and concentrate on this area. For example, this area, right? So if you know where the root, you get close to the roots. So this is the roots here. Okay, then remaining is computer to get the exact roots. Not exact, the computer calculated the very accurate roots value. So what you do is you take the one x1 which make fx negative, and x2 which make xx positive. The root must be between. So using computer program, you take the midpoint. This is the midpoint method. It's a very simple computer program. x3, if midpoint is here, okay, calculate fx3, and if positive, you repeat again. Negative, then you replace x1 with x3. So this range can be narrower. So you repeat 1,000 times using computer, then you get this R. Okay. Now there is a sometimes it's too slow. You have to repeat 1,000 times to get the roots. But when you use a computer to solve the polynomial, this is a method. Another method, there is the improved method. Suppose you have this kind of curve. What you do is you calculate the slope and take this point, okay, and slope takes this point. So this converge faster. But in order to do that, you need to know how to calculate the slope, and that can be, you will learn this in a calculus, is not in algebra. Okay, so the slope function is something else, but there is an improved method to calculate faster. But the simple method is midpoint method. This is midpoint. The computer can repeat 1,000 times. This get closer, this get closer, and determine this root. Okay, so that's the way to find the roots using computer for any polynomial. So the paper and pencil method, you can solve polynomial only when you are lucky enough to be able to factor it, and beyond that, you need a computer to calculate the roots. Okay, and the roots become very important later on. So you have to know actually how the engineer obtained the roots of the polynomial. With computer, pretty much you can do anything. You know that, right? Okay. Thanks for listening. I hope we'll see you in the next video.